I would like to welcome you all to the first seminar of the CSS seminar series of the fall 2025 semester. Today we have the great pleasure of hosting Professor Erdem Kabadayı, who will be speaking about a really interesting topic. Before giving the floor to him and without spending too much time, we have about an hour in the session. I will introduce him to you for those of you who are not familiar with his truly fantastic work. Professor Erdem Kabadayı received his bachelor's and master's degrees in economics from Middlesex Technical University and University of Vienna. He then pursued his PhD studies at the University of Munich, where he completed his PhD in 2008 in the fields of history and culture of the Middle East and Turkology, thereby becoming an academic historian of the Ottoman Empire. In the first decade of his academic career at the Department of History at Bilgi University, his research primarily focused on labor and financial history of the 19th century Ottoman Empire. Since joining Koç University's Department of History, his work has been guided by a broader overarching question. What are the historical determinants of population and economic growth, or the lack thereof? He has pursued this question through the establishment and leadership of multidisciplinary research groups. Between 2016 and 2022, he served as the principal investigator of the Urban Occupations Project, which is the first European Research Council project in the field of the economic history of the Ottoman Empire and Turkey. And more recently, he was awarded an ERC Proof of Concept grant, which brings together data science, population geography, remote sensing, and history. Over the past decade, his interdisciplinary research agenda has really evolved, developing and testing innovative methodologies that combine historical and contemporary textual sources with advanced digital and geohumanities techniques supported by GIS and geospatial artificial intelligence applications. His geographical focus is Southeast Europe and West Anatolia, with a temporal scope extending from the mid-19th century to the present. Professor Kabadayı, who has been a professor since 2023 at Koç University, produces very interdisciplinary scholarship at the intersection of history, digital humanities, data science, geography and earth sciences, and ecology, with, of course, numerous individual and co-authored academic publications across these fields. Professor Kabadayı also happens to be one of faculty members of the Computational Social Sciences Master's Program. So it is indeed a great pleasure to be starting the CSS seminar series of this academic year with the seminar. Without further ado, I know I spoke too much. I'm giving the floor to Professor Kabadayı. Hocam, let me enable sharing if that hasn't been enabled, so you can also share your screen if you want. The floor is yours, Hocam.
Thank you very much. First and foremost, thanks for the invitation and wonderful introduction. So I do not need to add anything to that introduction. And in fact, this presentation will be also tell a little bit about how I reached to this point. And the reason for that is that I think it can be beneficial for people connected to the computational social science program, because I've gone through an interdisciplinary path, and that path can be maybe also informative, or people can learn from my mistakes at least, so that when they are really trying to navigate through these disciplines, and starting from economics, moving to history, and then trying to move towards computational social sciences and spatial humanities, can be maybe relevant. Therefore, I will not only discuss and present the results of my most recent studies, but how I got there is also included in this presentation, and that's all by design. So I just wanted to highlight that. Thank you very much for the introduction. I'll go over those steps and try to really exemplify how I've gone to this point, and what was my journey through the disciplines and through different data sets. Therefore, it can be a little bit eclectical in this respect, what I will present, but I hope it will somehow make a bit more sense when I reach the end of it. And the time slot is about 60 minutes, or
Hocam,
is
we
it?
can extend it. I mean, we
Okay.
usually just spend, I mean, it's up to you, we can say.
All right. I mean, we are not a huge group, so I do hope that there will be a discussion, but then I'm planning to spend about 40 minutes. We will see on the presentation. I can go fast
Okay.
or slow, depending on the total number of attendees, but it would be great to have your feedback, of course, at the end of the QA.
Okay. Thank you.
But if you have a pressing question, I'm talking very small group now, that can be an advantage. Please stop me and ask. So you are allowed, and I would welcome your interventions during the presentation if you want to. Don't wait until then if anything is not clear. All right. Now let me share my screen and move to the presentation. And Mary Hocam, please let me know if anything goes wrong with the presentation now. I will go for the full screen. And
Okay.
if you have issues to see, please let me know. All right, now let me start with this. So spatial aggregation and disaggregation of historical population data is what we are working on. And although I'm an historian, I'm not currently focusing on historical demography or historical population geography. My main aim nowadays is to create data sets, long-term longitudinal data sets, not for the discipline of history, but rather for social sciences. So currently there are a massive improvement in availability of geospatial data sets, but they don't go back much in time with a higher accuracy. So our overarching goal, I mean first person plural, because we built up teams in this along the road. Our aim is to create longer term, more accurate historical geospatial data sets to use for not only understand today's changes, but also predict future developments in population geography. So that's the overall aim. So how do we get there? There are technical problems to do this, and scale is an issue, and aggregation, disaggregation of the geospatial data sets is the real challenge for us. That's therefore the title of the talk. Now, what are these problems, and how can we deal with these problems? So, major problem here is that we've got varying units of data availability, data acquisition. It is a problem if you want to create longitudinal data sets. What do we mean with that? So, if you want to really start not from today, but start from the mid 19th century or early 20th century, the spatial and temporal resolution of the population geography data is changing. What I mean with this is that frequency of the data acquisition or data availability, and also the spatial resolution, which means the data connected to these units or points do change. So that is the problem that we have. One way to go around this is geocoding spatial demographic data, of course, but this is the starting point. So how we do this is crucially important, and we have to build first, if we want to reach the longer term geospatial data sets, we need gazetteers, which means we need populated places in their exact coordinates with tagged population totals. So this is a starting point to do with it. And in our field, we don't have so many well-developed gazetteers. Therefore, in our research teams, we had to do this as a first starting point to use these data sets. Then, after creating these data sets, the unit of analysis is key. How can you operate to do which level you can aggregate or disaggregate the data is crucially important. There are three options normally in the literature. So you can operate with the administrative units, or you can try to reach internationally recognized units such as NUTS. This is in French, it's the nomenclature of statistical units, abbreviated. And in Eurostat and all other projects, it is a well-established unit of analysis. But there are issues with that because not every local administrative unit, this is LAU, is compatible with the not. So you have to aggregate or disaggregate or Krieg into the necessary units so that you can reach commensurability. That's an issue. Another option would be to try to really go to the point data, which means you can, as I mentioned with the gazetteers, you can have populated places. And this is, in fact, if you have the populated places, this is the smallest unit of data acquisition normally. And then you can aggregate to higher levels if you've got every populated place. I hope you can follow. This talk will be around these issues. So aggregation, disaggregation means for us, try to reach a commensurable unit of data acquisition and data analysis. And historically, data has been collected in the smallest unit is populated places. So the highest spatial resolution of historical demographic data is based on places where you can attach individual populations. I'll show you some maps. I hope it will be clearer. So this is what you can do with the historical data set. You cannot go lower than the populated places with the historical data sets. But in order to match these historical data set with the current geospatial data sets, there is a methodology to bring down the total population in an area into smaller units than the populated places. This is disaggregation. And for the spatial disaggregation, the common use best practice is gridded population data sets, which means either current or historical data on population is divided into cells in GIS. So what we are trying to do is, in fact, gridding the population into the cells, which can be aggregated to any unit using geospatial data science methodology. So that's our main problem. And only through the gridded population, one can overcome the modifiable aerial unit problem. So in GIS, or in general, in spatial data sciences, modifiable aerial unit problem is the issue which ties our hands to do longitudinal studies because we cannot reach commensurability. So the entire talk and what I've been doing for quite a while is trying to solve the modifiable aerial unit problem for a longer period in a large scale territory. So that's is this talk about. So that's the challenge of scale, aggregation, disaggregation. The entire thing is trying to find a solution for modifiable aerial unit problem. I will exemplify this in a minute. And the focus will be on the gridded population, as I've said. And a definition would be good. I think I'll just put a definition of this. So the idea is to really distribute the population to equal cells. These cells can be 100 meters to 100 meters. That adds up to 1 square kilometer. This is the best practice which we reach today. So we can distribute the global population into 1 square kilometer cells worldwide for a period starting from 1950. And we are trying to improve the quality of that data set. So that's what's going on. There are some competing projects to do this in the the most accurate manner. And among these four most common gridded population, global gridded population data sets, global human settlement layer from the European Union is the forerunner. So that's the best model to spatially disaggregate global populations across time to 1 square kilometer units using geospatial data sciences. And we want to improve the accuracy, spatial accuracy of these global data sets. And also, through increasing the spatial accuracy, we want to also increase the efficiency of predictions of future developments of population geography. So that's the aim. So I've spent about 5-10 minutes to this, but this is the problem that we are trying to solve. Therefore, I wanted to put it there. I will revisit and finish this talk the way we introduced our methodology to go beyond the quality provided by global human settlement layer. And that will be the end of the talk. But now I would like to take you back to the path that we followed with larger groups and how we reached to this point. Now, it all started with the ERC project. Mary Hocam has kindly introduced to that. So I will make these slides also available. You got the URL at the end of almost all slides which is connected to this project. It was a starting grant. We had a large group. What is important for us is that we started as a history project. Mary Hocam, am I too fast?
Not
Nice.
at all, Hocam. I think it's a great pace
Thank you
for
very much.
students to. Thank you.
Thanks a lot. So this project is, I was an historian when I got the grant. I started as a historian at the grant, at the beginning of the grant. So in the first, how many years? First 4 years, I was also collaborating with the Faculty of History in Cambridge, but then we've started to move along these things that I've just told to you, moving to spatial data sciences. So we've switched the partner to the School of Geographical and Earth Sciences at the University of Glasgow in the last 2 years of the project. And for us, it was important because our research agenda was try to conduct, as I've said, the longer term historical demographic and economic geography. And our questions, research questions, were really focusing also on urbanization. I will not get into the detail of this, but urbanization or changes in the population densities are also extremely valuable for economic history perspective, because for several periods where we lack data for the economic performance of units of settlements, their population can serve as a proxy data, and urbanization and changing population geography is extremely important also for economic history purposes, but at the same time, they are also key to understand the long-term land use and land cover changes. So when we were moving along these developments, and we reached the end of the urban occupations project, and then we wanted to focus more on the land use and land cover changes. And for that, we really wanted to go beyond the disciplines of quantitative economic history, and that we started to really collaborate more with remote sensing and geomatics and GeoAI. Therefore, we applied and thankfully got another grant, which has been mentioned also by Mary, that was focusing on examining major forms of land use and land cover change, but focusing on geography and also population geography specifically. Therefore, the rural depopulation, urbanization were key things. And in this project, when we've applied for it in 2022, we've already suggested in the application that we will improve the global human settlement layer. So these links are active. You can take a look at them. But when we've applied, Google Human Settlement Layer was going only back to 1975. Now, I mean, since last week, they went back to 1950. And that's very current. I will get into these details a little bit because which day what happened is interesting. In the last 2 weeks, a lot has happened from my perspective. But when we applied for it, global human settlement layer was not going back in time to 1950s. Now it does. And our idea was to improve the global human settlement layer for 1970s, 1980s. That was our aim. Therefore, we've got these cross sections. And for land cover change, Google Earth engine, or the new name of it is Google Earth AI, is also going back to 1984 at the moment because of the satellite data availability. But I think they are also trying to pull it back to 1950s. I will not be surprised if they will not go back to 1950s quite soon. So there is a research dynamic going on right now to create these longer term data sets. And I'll get back to this at the end of the talk because it is not only to help the historians, but it is to increase the temporal resolution of reliable data sets so that you can achieve a higher efficiency in predictive modeling. We can revisit this. This is an important aspect. Now, and just quickly, in this project, we've also had collaborators, of course, I should mention, Elif Sertel from Istanbul Technical University and also Pete Garretts from Glasgow University, who has just finished his PhD in geospatial data sciences. And at the moment, I've got also two co-authors in the audience, Grigor Boykov and Efe Erunal. Their name will be also mentioned soon because we work together and we publish together and we are continue to working together with these colleagues and friends. Now, still, going back to this modifiable aerial unit problem. So when we are developing our data sets, we went back to the censuses of 20th century Turkish Republic, and we've tried to create these sub-districts with geospatial methods, such as polygons using historical GIS. So if you want to work on these places, for example, in 1927, you have 328 sub-districts. And the next good census is from 1935. And then there's a change in the number and also geography of these places. Since the data that you can acquire is connected to those polygons, when the polygons change, you lose the commensurability. This is the problem of a modifiable aerial unit problem. So if you move further in time, for example, in the Turkish case, in 1970, we have about 600 units. And in 1990, this reaches in even higher numbers. I'll go to that in a minute. So we cannot operate with these administrative units. We have to go down to a smaller unit of data acquisition and also data analysis. And for this respect, we had to create a gazetteer with tagged populations starting from 1840s. And this is a collaboration between two projects, Urban Occupations project that we've led here, and Grigor is with us here. And Grigor had a Marie Curie project hosted also at Koç University called PopGeo Bulgaria, and that is also historical population geography project. We've created a data set of a larger territory with tagged populations. So the reason we did that is that you can aggregate individual populated places to your selected administrative boundary. I'll just exemplify this a little bit. Since I'm an historian, I'll go over that, and I think it's important. So let me show you how we operated with this. This is the project that I've just mentioned from Grigor Boykov. That's the Marie Curie project that he ran here. And then he had to move to Vienna. And right now he is a member of the faculty member of the University of Vienna, but back then he had to leave for Vienna, but he's still working on creating these historical data sets. And we recently published, this is 2025 publication in the second item on the list. And in that publication with Pete and Grigor, we've tried to make use of these populated places and create longer term longitudinal historical data sets by making use of these points. Very quickly, bear with me, I'll just take you to the late 19th, early 20th century Bulgaria to exemplify how we can use these populated places. So these points are coming from our gazetteer from 1840s. And then if you have these points there, you can aggregate to a larger unit. And we've just opted for 1892 administrative units. If you georeference these administrative units, that's the beauty of GIS. You've got the points in their exact coordinated places. You've got the polygons coming from historical maps. Then you can aggregate the 1840 data to 1890 polygons. So it is then possible for us to create a map which hasn't been done before. Map making starts in late 19th century. Our data is from mid 19th century, but we can make use of existing administrative structure from a later period to reach commensurability. So we worked on this, and then it was possible for us to aggregate these point data to several longitudinal observation points from 1840s up until 1930s. So we were happy with this as historians, but this modifiable aerial unit problem still sustains. As you can see there, the polygon shapes are changing because the administrative unit is changing. So it's a solution to this problem, but it is not an efficient solution. So one can go further down on the level of spatial resolution. So it is of course useful for us since these are polygons of GIS polygons. So for example, you can put that on today's world on a digital elevation model. You can even include environmental factors and variables into your examination, but the unit of analysis is still not satisfying and it doesn't create an efficient longitudinal data set. Therefore, we had to really break down these populated places to the cells. This is what we wanted to do. In order to be able to do that, one should still acquire data to the exact coordinates. So if you want to grid the population to the cells, you still have to acquire or create data sets, let's say, of gazetteers with geotagged population, which means you have to locate the places, the populated places in the censuses, and attach them to their exact coordinates with the population totals. Then we've started to do that. Thankfully, we had a larger team. I will not mention everyone here. You can visit the URL down there to see the long list of co-workers in this. But after painful work, we managed to geolocate around 15 to 17,000 locations, first for 1935, I'm sorry. So this is a gazetteer that we have created. Unfortunately, Turkey doesn't provide Turkish institutions or any institution. They don't provide gazetteers even without the population data. So we had to create geospatial data sets like this and attach the population totals. We've done this for 1935, 1955, 1970, sorry for the color choice, it's blue on blue, then 1990. So technically now, if we have additional data sets, we can disaggregate these population totals from the points to the cells. So that was the work we had to do before going into this process. And now I'm moving a bit further towards geospatial data sciences. This was the raw material, let's say ingredients to do that task. We had to create these data sets. And now for the methodology, we wanted to copy and even improve the best method around, and that's, as I mentioned, the global human settlement layer. Now I'll take you to the methodology of the global human settlement layer and how we want to improve it. In fact, we did, we think, but I'll show you that, and I may convince you or not, we will see. So now we've got the material. So what is the material? In the gridded population practice, the best practice, you've got two types of data sets. One is these census data. It can be historical or current, but normally right now people are using also historical data sets, as I've just said, back to 1950s. So you got these census data, which are normally bound to administrative units. So you have data sets for Sarıyer, or let's say sub-districts of Istanbul. And then in some cases, you got only data back in time for the entire Istanbul district. But you have to this data connected to the polygons. And then you want to create a separation of that data according to the urbanization and according to the location of the settlements. And in order to do that, you need satellite data. So that's the census data. I hope you can see my cursor here. And then here we've got the satellite data. This is from NASA, and the earliest data, satellite data, which can be matched to the census data, is from 1984. This is the very first satellite data which we can use, or the global human settlement layer uses, and that's the Landsat. And before Landsat, we cannot go deeper. It's just a back projection. So the satellite data availability starts from 1984. This is the reason that Google Earth cannot go further back in time earlier than 1984. And this is the reason that Google settlement layer says 1975, but it's a back projection. And the new terminology which is being used by these gridded population practices is backcasting. So that's the new term. They don't use back projection, but it's backcasting. And this is the model. So you backcast the distribution of the population by making use of older historical spatial data coming from the satellites, images, and also historical data sets. And they improved the spatial resolution of this. They started with 1 kilometer to 1 kilometer grids. Right now, currently, they are operating with 100 meters to 100 meters grids. Therefore, we've got 1 square kilometer grids. And the idea is to create a global data set. So this was when we've started, we wanted to improve this, as I've said, both pull it further back in time back to 1950s and also increase the spatial accuracy. Now, there were some already critiques of these global data sets back in 2022, like underestimation of populations, because it's a global data set, it's very difficult to reach higher accuracy on a global scale. And most recently, very recently, in fact, this year in Nature Communications, there was a very critical work. But this was before we applied for the project. And when we were working on this, we've got this population as well. Sorry, we got this publication as well to confirm the problems with the data set. And it is an ongoing process, and the global human settlement layer has also improved itself in the last year. And let me get into the exact dates of this. So we've just published in 2024 our methodology to make use of an earlier satellite imagery data set, which is globally available, to improve the global human settlement layer. That was the publication from 2024. And 10 days ago, 8 days ago, we've just finally got, I think, an important, let's say, we reached a threshold to improve the global human settlement layer with our earlier satellite data set. We've just submitted this publication on the 3rd of December, and it is under review. And Efe is a co-author of this publication, is the second author, in fact. And the Pete has been doing the geospatial data science behind that. And we were targeting improving 1970s global human settlement layer. And one day after we submitted this, just by chance, global human settlement layer improved their 2023 version. And now they go back in time to 1950s, but our results are still, in our mind, better and higher resolution accuracy they have for 1970s. But technically, we can also go back to 1950s. So I'm quite excited. So we've already tried to improve 1970s data sets, and it was not possible for us to argue that our 1950 is better because they didn't have 1950, but now they have 1950. It's a moving target. So our next publication should try to improve 1950s resolution. So in the remaining 10 minutes, hocam, at most, I'll go over the technicalities and then conclude. So let me take you briefly to the nuts and bolts of this global human settlement layer and how it operates. So the one we've targeted, it is I hope you can see the movement. So this is the 2023 version of the global human settlement layer. And here down, you can see the resolution of 1 square kilometer, and it's a data set starting from 1975. So this is, I've just picked Istanbul, but you can go anywhere. This is the beauty of this data set. It is global. So globally, they are backcasting the change in urbanization and the way, by the way, the legend of the map is red is urban. You can imagine we are all in Istanbul. I think we are all, except one colleague from Vienna. So we know what we are talking about right now. And so we've got urban, rural, color coding is there. And this is the urban expansion of Istanbul from 1975 until 2030. So they just predict 2030 with the 2020 data set here. And since in the predictive modeling, you've got several data points back in time, they've got the claim of a higher accuracy in their predictions for 2030, since the data set go back to 1975. And last week, starting from the 4th of December, we've got the upgrade. And this is the upgrade. The upgrade now covers the period from 1975 until 2100. It's difficult to even pronounce the date. So now they go back in time to 1975, and they are trying to predict the changes in population geography in year 2100. So they are predicting 75 years ahead. And you can take a look at this because in some places the population doesn't peak. So here Istanbul population is expected to be peak 1950s. If you go for and take a look at Cairo, Cairo continues to increase until 2100. So in this regard, this is the new product which is available in the last week. And we would like to really go back and take a look at that and try to improve it. And this is the information which is available from the data set from 1950 to 2100. So they've got three methods here, three periods, and the way they calculate these data sets, and they really need to use the satellite data. But they are still backcasting, as I've said, 1970s, 1980s Landsat data. And that's problematic because the Landsat data doesn't have the spatial resolution. It doesn't lend itself, in fact, to backcast back to 1950s. And they underestimate the rural population. So in the last 5 minutes, I'll show you our claim that we are doing that better than the global human settlement layer. Let me go back to the presentation and show you the details, how we can do this better. Now, our data set that we are using is coming from a reconnaissance satellite imagery. So it's in fact American spy satellites, which were operating until 1986. I can go into the details if you're interested, if there will be time, but it has a global coverage. So they were aiming to spy on the Soviets, but if you go not fly over the Soviets like U-2 spy airplanes, but if you go for the satellite, you got the global coverage. So the aim was to mainly uh, spy on the Soviets, as I've said, and the China and Cuba, etc., in the Cold War. Since they had the global reach with the satellite, they've got the global coverage. And this data set has been made available in 2022. It was not available before. Now, USGS GS made this available and we've downloaded. And I think we are the first group who published on this data set with this aim. So I'm happy with that. I hope there will be acknowledgement. We will see. I hope we will not be just stuck in a small corner of the Turkish academia. We really want to be a part of this global competition to increase spatial resolution of grid population data sets. It's a very promising data set. So we've got this data set, global coverage. And in our project, we just wanted to start with a local, smaller region. We've got 5 regions. This is Plovdiv, Filibe in Turkish in Bulgaria, a border region in Lalapaşa, Bursa, and then we've got 2 areas in Istanbul. And it's about a total of 2,000 square kilometers of area that we wanted to cover with this new material. So we also wanted to go back with the aerial photos. So this is the 1950s aerial photos, but I will focus more on this satellite imagery from 1970s and 80s, which is called hexagon keyhole number 9. So this data set has got an advantage, pros and cons. The real advantage is that it has got very high spatial resolution. It's black and white photos at the end, so we've got some problems with the bandwidth, but spatial resolution is key and very important for our purposes. So what we did was we've got these hexagon imagery and segmented the land use manually. So what you see, the red is the urban areas. And this is Çekmeköy, as you can see. And in Çekmeköy and in Arnavutköy, I'll just get into these examples with you. So it was possible for us to really trace back the development. And since we've got also the pointed population data, so we've got the populated places, it was possible for us to segregate the population to these cells in a better and more reliable version than the global human settlement layer. Let me go over this. So this is the methodology. This is the hexagon black and white photography from the satellites. This is to the left is Arnavutköy, where we had the new airport today, and that's Çekmeköy. So we've got the photos, and the red dots are the populated places. And in those places, we also know the total people living or registered as in the censuses for the matching date. This is for late 1970s. We've got 1975 census. This photo is from 1977, so it is matching. And then we just use this land use, land cover map to distribute, spatially disaggregate the population for this area. And which means, as you can see, we've got these places. These are the urban locations or residential areas, the red dots or the red territory. We assign more people to that. So since we've got a higher resolution in the data set, we can weight residential areas on a higher spatial resolution. So instead of just putting lots of people in the center of Arnavutköy or Çekmeköy, we can distribute more population to the other places. Now I will compare this with the global human settlement layer. This is the global human settlement layer distribution. So I'll go back. In our case, we can put people to these small villages. More accurately, global human settlement layer puts the most of the people, as you can see, this is urban, that's dense urban center. The rest is low density rural. So they underestimate the rural population. We can easily say that. They put most of the population to the centers, but the rural locations are not represented in the global human settlement layer. So in our case, this is our result, which is more accurate because it assigns population to places where people actually live. So that's the improvement that we will see how the referees will respond to this effort. But we've done this for Arnavutköy and Çekmeköy, but this can also be done in other areas that we work, such as Bursa or the border region of Lalapaşa or even Plovdiv, as I just mentioned, because we've got the same data sets, and we also can go over these residential areas, forests, or cropland to assign population more accurately. And since we also have the population data sets, we can match that and also predict possible changes in population geography. This is another publication. Efe is also a co-author of this one. And we hope to be, Mary Hoca has also contributed to this book, which has been edited by Akın Ünver. We are waiting for that. The book is ready, but there can be issues with the publication house. But so these are the data sets that we want to further improve our research and follow these issues. So my aim as a social scientist is not to improve the accuracy by number. I'm not an engineer. So I do not want to increase the precision just to increase the precision, but I want to model long-term population change to tackle these research questions. And therefore, although we need the engineers, and we have to build an international and mainly international and interdisciplinary team, our goal is not to improve the metrics. Our goal is to improve the usability of these data sets for longer term social science research questions. And in my last slide, I would like to highlight what we want to do in future. So we want to go from this regional perspective to larger area. We can even think about global availability and global implicability because of the datasets availability. And we've used manual data segmentation. We want to do this with automatically by using computer vision. And as I've just said, right now, the spatial resolution is to 1 square kilometer, but we can go even smaller as a unit of analysis, because if you reach the higher accuracy, you can even reach to smaller cells than 1 square kilometer. It's a possibility. You can go by pixel. And we want to go back to 1950s with aerial photos. And then possibility would be then to better estimate 75 years from now on. That would be our goal. Thank you very much for patience. That's what I wanted to share with you now. And I would look forward to any remarks or questions. Thanks a lot. Thanks for your attention.
Thank you so much, Erdem. I mean, it's always really a great pleasure to listen to your really fascinating work. This is truly inspirational. I would like to open the floor for questions our students and participants may have. But usually there is a certain lag there where people are warming up. I tend to start with my own questions using the moderator privilege, if you will. So that's what I'm going to do. But I'm inviting everyone to prepare their questions. They can just unmute themselves and ask, or if it's more practical, you can also put them in the chat box if that's more practical for you. Hocam, I mean, this is again, once again, very inspirational work. My questions are focusing on more practical oriented, if you will, issues. While listening to your talk, I wondered, um, if someone wants to merge your reconstructed population layers with socioeconomic or environmental data from different periods, what temporal alignment challenges should they expect to face? And this is, I think, a question that would, I mean, the answer would be helpful for our students who are interested in similar work.
Thank you very much. I think it's a good question to start with. You just said temporal?
Temporal alignment challenges
Yes,
if
got you. Okay,
they. Mhm.
perfect. So, first of all, I mean, coming from my corner of disciplines, so I would also like to work, of course, economic geography and historical economic geography. So, there are very important data sets that we can add up to that. So, we start with the population because we have more data on it, and it's very important if we are interested in social sciences, and it's very important to locate the people into their places. But then uh, agriculture would be very important. So, because it will be easier to connect to the land use and land cover change. So, agricultural censuses, agricultural production data, or if you want to go for the climate change, the total area of forests will be key. So, these will be the possible data sets that you can work with. And there, if I understood the question correctly, there are two ways to do that. One would be to use other possible available data sets, and their availability and their spatial limitations will set the limits of commensurability. If you want to go for, let's say, agricultural production or forests or deforestation or all these questions, either you go for textual sources and try to bring that data, extracted data, coordinated, put it in the GIS layer. So that will be one option. But you can bring other data sets, health, as I said, education, human capital. So it doesn't really matter. But if you have textual data created by other sources, this textual data has to be specialized. So you've got education, health, life expectancy, you name it. You've got these data sets, and there is a spatial resolution to that. Either they are aggregated to the national level, disaggregated to the normally, let's say, sub-district level, but these are normally connected to the census making. And if you do the censuses, you normally have a higher resolution, spatial resolution for the data acquisition, but the data is not available on the level that they've acquired. So we social scientists, if we want to go for Eurostat, Turkish Statistical Institute, UN data sets, they are all aggregated to higher levels so that we can work with it. In fact, they are acquired on a higher spatial resolution, which means to the smaller locations. But unfortunately, we do not always have the data on the spatial level that they've acquired. So they are aggregated. In order to use our methodology to the full extent of its capability, you have to disaggregate the aggregated data. Could you explain myself? So in the census making period for Turkey, it is from 1927 until 2000. Every house was knocked on, every door was knocked, and they collected the data per household. But we don't have that data in that spatial resolution. If you go to the Statistical Institute, they will give you aggregated data either to the district or the sub-district level. So interestingly, we reverse engineer what has already been aggregated. I hope I didn't, I hope I understood your question correctly.
Yeah.
And that's
Yeah.
the problem. The data acquired in a very wonderfully matching spatial resolution to our perspective, but they made it available on a higher aggregation level. And we have to disaggregate that. That is the problem. With the temporality, we have this spatial issue. I hope I could answer this.
Oh, Jam, you did. Thank you so much. And I mean, since this is very much like beyond the scope of my own work, I mean, I have a couple of questions in mind. I'm wondering how our students, if they are into this line of work or researchers, interpret areas where your model returns in some low confidence predictions. Should these zones be excluded, weighted differently, or I don't know, used more
Yeah.
maybe cautiously?
I mean, very quick. I don't want to really monopolize this. Maybe there will be other remarks, questions,
Yeah,
critique.
sure.
But we shouldn't. I mean, what we are doing is, in fact, trying to really compete with a global data set, but
Mhm.
on a smaller scale. So, in fact, what we want to do is to really test the applicability of these global data sets for smaller areas, first in our case, and to make suggestions to improve those data sets. So we are not here to criticize and global data sets and say that no, they are not working. No, that's not our aim. So our aim is to refine the methodology so that the global data sets can have reach a higher accuracy for the localities. So that's our long-term goal. But on the way to
Mhm.
reach that goal, our students, my possible co-authors of other publications, or let's say collaborators, we should be careful about where we can. So we have to be selective with this methodology. So for instance, we cannot work on Central Anatolia much for the mid 19th century. So there are historical contextual limitations. So since we are not pursuing a global goal, except making suggestions to the institutions who are creating these global data sets, I think we have to be more conscious and careful about the reliability of these tools. And if we have the context, then we can reach to a well-educated guesses about possible outcomes, and we can also be more careful about the possibility or applicability of these methods with the data sets. So in some locations and for some temporal areas, we can warn co-researchers that there can be problems to bring that data set with that methodology. So we can
Mhm.
provide the insight.
Okay, thank you so much. I mean, I have some other questions, but I also would like to give the opportunity to the audience to ask their questions if there are any at the moment. Um, but if not, I my next question is more about collaborations. I mean, how do you envision um, collaborations between historians and computer scientists evolving around these data sets. I mean, and this is the question that I will be asking to all of our speakers in this series because it's the Computational Social Sciences seminar series. Are there any specific methodological gaps that interdisciplinary teams could address, you think? And since we were both in the interdisciplinary breakout session in the AI retreat we had, I think back in, was it June or July? I think it was a while ago,
It was
but
warm. It was
um
warm. I remember. It should be summer.
yeah. Yeah, right. So maybe we can start with this and move on to audience questions later.
Sure. I've been thinking about this for quite a while because, to be honest with you, I mean, thank you very much for that, Mary Hocam. So we've discussed this. How can we facilitate these interdisciplinary collaborations? And our university has got a wide spectrum of disciplines, so therefore we do not need to even go beyond what is available on campus. But how can we really bring these areas together, colleagues together, so that especially for computational social sciences, there can be a higher level of readiness, higher level of openness to collaborate. So I've tried and failed several aspects, I mean, several methods, to be honest with you. So if you just, I think, try to initiate collaborations with guest researchers from other disciplines, let's say special data sciences, computer sciences, geomatics, towards social sciences. There are problems there. I mean, we've discussed this several occasions with you and other colleagues. Maybe people are listening right now can also, I don't know, maybe they are pursuing their MA projects, possible PhD projects. So it is not always easy to collaborate with computer scientists to ask for their time for a possible output of an MA dissertation or maybe a publication. So from my point of view, it was really difficult to convince people that we can move further and beyond together. So it is not only borrowing their toolbox or getting their help. So I think we can really push the boundaries of both disciplines or several disciplines together. But it is difficult. So my possible solution to this, or not a solution, but my next try, I would say, would to go towards meeting with these people, let's say data. I hope there aren't so many engineers or computer scientists in the audience. I'm not trying to really criticize them, and I'm not trying to say, hey, us and them. I'm not doing this. But I think in order to be able to really convince people that we can move together beyond the existing limitations, can be complexity science. That's my new idea, which means instead of just bringing people from the engineering to our field, which can be said as, let's say, social sciences, we can meet somewhere else on neutral ground. And instead of just bringing computational capabilities from the engineering field to social sciences, we can both go, me from social sciences, possible collaborators from engineering or data sciences, and meet at a new place, and that can be the complexity science. So complexity science is emerging, and I think we, as a program, as a as a research group and center on computational social sciences, we should try to really be more present at these venues. They've just started this. There is computational complexity science conferences, and the journals are coming along. There are institutions assigned for this. Complexity Science Hub is an example. That is kind of a neutral ground to come together and move beyond together. That's my naive suggestion. We will see whether I'll try and let you know whether it will be easier for me to collaborate with colleagues from complexity science.
Well, I think that's a fantastic idea, and we certainly need to put more effort into, I suppose, being part of this initiative in a way as the center, and we also have an MA program on that. So I think that's really very exciting. So we could also invite all of our students to take a look at this.
I can recommend. I'll
Uh,
yeah.
that'd be great. Thank you so much, Erdem. Well, actually, I mean, we're already past our first hour, so I mean, we can expand a little if there are any questions, but if not, then I would like to take this opportunity to thank you so very much, Erdem Hocam, for this really inspirational talk. I'm sure all of our students also enjoyed it very much. It was a great debut, I think, to the seminar series of the 2025-2026 academic year. So we will have more seminars throughout the year, and we will be hopefully posting the rest of the list, share it on our website and also on social media platforms. And we have, Shukra, I believe we have two more of these talks this semester, and then more of them in spring, right? Or maybe even
Yes hocam.
three, no, two.
Uh, I'm not three, I think hocam.
I think three.
Three
So the
remaining in
last one
this
is
session.
like after the final period is over. It's like in between, kind of. So yeah,
Yes hocam.
stay tuned, everyone. We will be posting them. But once again, thank you, Hojam, so very much. And with that, I think we can stop recording.